Hello and welcome to Tribetopper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video session, you are going to learn about a nuclear power station, how it produces the electrical energy. So, the basic phenomenon that is responsible to produce energy would be the heat energy that we are going to get from a nuclear reaction. So, this is a nuclear reactor that you can see, and you have the uranium fuel in the form of uranium fuel rods. And this is a steel reactor vessel. There are graphite moderators. The problem with the nuclear reaction is that there's a fission reaction which happens here. So when this uranium fuels rods or uranium nucleus, it is bombarded with a neutron, a fast moving neutron. It hits the uranium fuel, produces a new daughter nucleus, but along with that it produces three neutrons. So what happens is that you have one neutron, it hits and produces three neutrons. Then those next neutron is going to hit another uranium nucleus and produce three more neutrons, three more and three more. So one neutron produces three, three produce nine, nine produce 27 and so on. So like a chain reaction is set up in a nuclear reaction. So a large amount of energy will be produced, which is of course useful to produce that enough amount of heat. But the problem with the chain reaction would be that it will go uncontrollable and cause destruction. So as you can see here, we are using the control rods and moderators. So the control rods are the ones, what they do is they're generally made up of cadmium. The control rods, they will absorb the extra neutrons. So that like when a neutron hits and produces three neutrons, out of those three neutrons, two will be absorbed and one will be left out to carry on the further reaction. So that way it becomes a controlled chain reaction. And the moderators, the graphite moderators, they slow down the neutrons. So control rods absorb the neutrons. This is important to remember because sometimes it is asked in a 1 mark question. And the graphite moderator, that slows down the neutrons. So you just remember the difference between the two. So then whatever the nuclear reaction happens here, the daughter nucleus is produced and you get a large amount of energy. Now that heat energy, what does it do? As you can see here, we have the cold water that enters, and that cold water, it remains in this heat chamber for a long time. The heat is the one that we got from the nuclear reaction. So that heat energy is being provided in this chamber. The cold water enters from here, remains for a long time in this chamber and comes out as steam. So the steam is going to drive the turbine, which rotates actually a coil with a large number of turns within the magnets, strong magnets, and that produces electricity. So basically the final process is same in most of the power stations, that you have to rotate a turbine which rotates a shaft on which a coil with a large number of turns is wound, and when a coil with large number of turns is rotated within magnets, it produces electricity. There's a phenomenon called electromagnetic induction, which you're going to learn about in topic 11. But that's the basic phenomenon which is responsible, that whenever a coil is moved within a magnetic field, it induces an EMF. So that process is same, the end process is same every time. It is based on electromagnetic induction, but how you rotate the turbine, that is different in each case. So in this particular case, the nuclear power station, we have the heat produced from the nuclear power station which produces steam, and that steam, high energetic steam, falls on the turbine and rotates the turbine to produce electricity. So that's all in this video session. And you've learned how the electricity is produced in a nuclear power station. In our next video session, you are going to understand how the electricity is generated by wind generators. Thank you.